Welcome, everyone. This is our Science Communication 101, presenting your research to diverse audiences. My name is Janelle Simmons. I am the Manager of Programs at Sigma Xi, the Scientific Research Honor Society, and you are in for a treat today. But before I get started, we have a few housekeeping rules. Please make sure to mute your audio to minimize any background noise. Use the chat feature to send questions to only the host, co-host, and the presenter. There may be some times during the workshop where the chat will be open for each other, but anything prior to that or after that part of the program, you will just be able to chat with the co-host and the presenters. To ask questions verbally, please use the raise hand function and you will be prompted by the host to speak. We highly encourage you to have your cameras on during this workshop as it is interactive. And also this workshop, just so you know, is part of the Science Communication, Education, and Public Engagement track at our upcoming annual meeting and student research conference taking place online November 4th through 7th. And that track is co-sponsored by the Borough's Welcome Fund. At this time, I would like to introduce to you Fenella Saunders, Editor-in-Chief of American Scientist Magazine and the Director of Science Communications and Publications at Sigma Xi, who will introduce our speaker.
Thank you, everybody, for joining us today. We're really excited to have you here. We're hopeful that this will be a very useful session for you, especially if you're considering presenting at the meeting or in any other communications that you might be doing. It's always our honor to have with us today Jory Weintraub, who is going to facilitate this entire program. Jory is a trained scientist with 25 years of experience in STEM communication, outreach, and education. After completing his PhD in immunology, he received an NSF postdoctoral fellowship in STEM education and outreach with a focus on diversity, equity, and inclusion, and creating and running education and outreach programs to increase participation of underrepresented minority students in STEM. He then spent more than 10 years directing the education and outreach efforts at an NSF-funded evolutionary biology research center, where he refined his expertise in communicating controversial science. Since 2015, his primary focus has been teaching science communication courses and running science communication workshops. He is currently the Science Communication Director with the Duke Initiative for Science and Society and is a faculty member at Duke University, where he teaches science communication courses for undergraduate and graduate students and provides science communication training to faculty, postdocs, and staff. He is also the founding director of the Duke Broader Impacts Resource Center, which supports Duke researchers' efforts to develop outreach and public engagement activities to complement their research. So, Jory, please proceed.
Great. Well, thank you so much, Fenella and Janelle and Iman and everyone else at Sigma Xi for inviting me to speak today. And thanks to all of you for attending, especially on a Saturday. I guess you're all over the country, maybe all over the world. I was going to say a Saturday afternoon, it may be Saturday morning, maybe Saturday night where you are. But regardless, I'm really glad to see so many people turning out, and I will hope to keep this a very lively and active session. So I encourage all of you to feel free to keep your cameras on so that we can sort of engage visually. Feel free to use the virtual hand raising function. If you have questions, I'm happy to pause at any point to answer questions that you may have. We'll try to, build in, it's a 2-hour workshop, we'll try to build in a couple minutes for a bio break if anyone needs that. Let's see, any other business I want to mention? Oh, I guess I was going to just say that I'm happy to share my slide presentation with any of you who are interested. My email address is on the screen right now. It's very simply just my name, jory@duke.edu. And so if you're interested in getting these slides afterwards, just shoot me an email and I will be happy to send the slides to you. With that, I will jump right in and again, encourage you all to ask questions, raise your hand if you have questions at any point. So I call this talk Science Communication 101, presenting your research to diverse audiences. And I always like to start with this silly little cartoon that I found. I think I found it on Facebook or Twitter, and I grabbed it because I thought it was actually a really good way to start off my sessions on my workshops and trainings on science communication. So take a look at this little cartoon, and I'm assuming that for many of you, this actually resonates. And as you read this, you probably are thinking that you've experienced something similar. I know I certainly have over the course of my career, especially early on in my career. I've been doing science and science communication for quite a long time. And when I first started doing research, we're talking almost 40 years ago, there was very little conversation about how to help scientists more effectively communicate their work to non-experts in the field. And so certainly early in my career, I experienced this a lot where I didn't really know how to tell my friends and family what it is that I did in the lab. And they seemed impressed, but I really got the sense that they had no idea what I was talking about. And that was because I was not doing a good job of helping them understand. So if this cartoon resonates for you at all, then hopefully this workshop, this session will help you feel maybe a little bit more comfortable with communicating what it is you do, the research that you do to non-experts. That's really my focus now, is helping scientists and engineers and other people who do research communicate their work more effectively to non-experts. And really what I always tell people is that the essence of science communication, the real goal of science communication, is to help people understand what it is that you do and why that matters to them. Right. And a lot of people just assume the first part, right, that science communication is about helping people understand what you do. But what we know, and we actually know this from research, from empirical data, we know that if you don't help people understand why it's relevant to them or why it matters to them, then most of the time they just won't engage with it. Or even worse, they will actually take an anti-science view and be less likely to take in the science and subscribe to the science and accept the science if you don't make it relevant to them. So this is really about helping you understand more effective ways to communicate what it is you do and why it matters to your audience. So that's really what we're going to be focusing on. And so where do we start with that? I mean, this is a big challenge. And again, it's something that a lot of scientists, especially older scientists, haven't really received training in how to do this. And so, over the years, we've collected data and we've done research to learn what works and what doesn't work with science communication. And so a lot of what I'm about to share with you is most of what I'm about to share with you is based on empirical evidence, on research that tells us what works and what doesn't work. And I always like to start with this interesting image, which you may be looking at and thinking, what does this have to do with science communication or research communication? Some of you may recognize this image. This is actually the Louvre Museum in Paris. And if you've been there, you've seen the big outdoor structure, the big glass and steel pyramid that is the entryway to the Louvre. Really sort of beautiful architecture designed by a well-known architect named I.M. Pei. And this is actually the inside, the underneath of the Louvre, where there's a smaller couple of pyramids, as you see in this picture. And the reason I'm showing this is because, a symbolic sort of way, this actually represents the way scientists and researchers have typically been trained to communicate what they do to each other and how they've tried to do that with the public as well. So let me explain what I mean by this. If you look at the upper pyramid, what you see is that it's an inverted pyramid and there's a very large area at the top and it gets narrower as you go down. And this is sort of representative of how scientists have traditionally communicated their work with each other. And what I mean by that is that scientists will typically start with background and historical perspective. A typical science publication or science paper will start with sort of the history of the field and all of the experiments that have been done in the past, and really setting up all of this background information before they eventually work their way down to what's being discussed in this particular paper and how it's relevant to the audience. So they take an almost inverted approach where they start with background and eventually work their way to the point of their particular research study. And what we know is that when you're talking to non-experts about what you do, this approach generally doesn't work very well, because most people who aren't experts in the field don't really care that much about the historical perspective or all of the history of experimental work that's been done previously. Mostly what they want to know is, why should they care? Why is this relevant to them? So to push this metaphor as far as I possibly can, what we encourage people to do is to lead with the point, get to the point right away. And that's what you see in that lower pyramid. You start with the main point, why this matters to your audience. Because if you can't convey that message of relevance, they're just not going to pay attention, and they're probably not going to read on or listen to your talk any further. So we recommend that you always start with the main point of your work. And then if you want to present some of the background and perspective, then people have the choice of reading on and reading later down in the article and getting that historical perspective. But as a starting point, I always advise people, when they want to communicate their work to non-experts, lead with your main point. And the main point is, why does this matter to your audience? Okay. And in the science communication business, we call this your message, right? We talk about message all the time. And in my courses that I teach in science communication, my students hear this over and over throughout the semester. What is your message? What is the main point that you want to convey to your audience? And that message is really what I said earlier. It's what you do and why it matters to your audience. I often describe the message as sort of the equivalent of a headline of a news story. So in a headline, right, what you see is 7 or 8 or 10 words that pretty much summarize the whole story. And so if you're looking at a news website, if you're looking at CNN or some other news website online, you're going to scan the headlines and you're going to make a determination based on those headlines of whether you want to click on that link and read that article. Okay. And so if you don't grab people's attention and let them know that this story is relevant to them in your headline, then they won't read. And that's exactly what your message is. Your message is the summary of what you do and why it matters to your audience in one sentence, in 8 or 10 words. And so this is a tall order. This is, I'm asking you to do a lot of work here by communicating the meaning and relevance of your work in a single sentence. And I'm actually going to put you to work in a second and ask you to actually practice doing that. But before I do, I want to clarify that your message really needs to have several features in it, including the points you see on the screen. So it needs to be easily understood, which means it needs to be communicated in a way that's accessible to your audience. It should be memorable so that they take that message with them and potentially even carry it with them and pass it on to others. And it needs to stay focused, right? Scientists often have a tendency to go off on tangents and to get really excited about all of these related projects that they're working on. And they'll try to fit all of that into one sentence, right? But your message needs to stay focused. You need to be very clear that you're communicating a single idea with your message, all right? So think about how you would summarize the essence of your research, what you do and why it matters in that single sentence, because I'm going to ask you to do that in just a moment. First, I want to mention that in addition to message, another really important thing you need to keep straight in your head is, who is your audience? Who are you speaking to? And again, if you take my semester-long course that I teach at Duke, you're going to hear that over and over. What is your message? Who's your audience? These are two of the most important elements of communicating your work to non-experts. And when I say non-experts, I just want to clarify, that could be really anyone. It could be, your friends and family. It could be, it could be other scientists who work in different areas of science. It could be, for those of you who might get asked to do an interview at some point to talk about with the media about your research. It could be talking to the media. It could be talking to policymakers who want to make policy decisions based on your research, right? So there are lots of different audiences that you might speak to. But you need to know who your audience is so you can frame your message for that audience. Now, what do I mean by framing? Framing is really the context in which you deliver your message. I sometimes describe it as the wrapping paper of your message. So, for example, if you were going up to traveling to Washington, D.C. to meet with some Congress people to talk about your research, you would want to frame it in a context that was relevant for policymakers. You might want to talk about how it's relevant to, science policy, or how, new policy based on your research might save the taxpayers money or reduce medical expenses and bring down health costs in this country, right? So that's the kind of framing that you want to think about when you're talking to policymakers. Now, if on the other hand, you get invited into a classroom full of second graders to talk about what you do, they're not really going to care about healthcare policy or taxpayer dollars. Those aren't the things that concern a second grader. So you need to think about how you're going to deliver your message in a context that will be interesting and engaging to them. And the message itself doesn't change, right? The meaning of what you do and why it matters is the same no matter who your audience is. But the framing or the context, the examples that you use, the setting, the wrapping paper, that's going to change depending on who your audience is. So I get asked this question very often. Well, what do you do if your audience isn't just a very homogenous group, right? A classroom full of second graders, or a chamber full of senators, right? People who all are pretty similar. What do you do if your audience is a mixture of kids and adults and people who might have some science background and people who have no science background? It's a really good question, and it does make your communication more challenging, right? How do you communicate a single message framed in an appropriate way to a very diverse audience? And it's a challenge for which there's not really a perfect answer, but my general advice is it's always safer to frame your message and communicate your message in more basic terms to start off with, and then watch your audience and see how they respond and see how they react. And if they seem to understand what you're saying and they have questions that bring the conversation to a higher level, then you can respond by giving them a deeper explanation, giving them more technical explanations for the things that you do. But it's really all about starting at a level that's accessible for everyone. Now, if you start at too high a level and you start using a lot of scientific jargon right out at the beginning, you run the risk of losing your audience. And then once you've lost them, it's really hard to get them back. So in general, it's safer to start at a more accessible level and then respond to your audience's questions and get more technical as they ask questions that demand that. So that's sort of the best advice you can give. But the bottom line is that if you have a really diverse group of audience members, it can be sort of challenging. I've done a lot of outreach in museums, and when you talk to the public in museums, you're going to have little kids, and you're going to have teenagers, and you're going to have adults, and the adults might be scientists themselves, or they might be accountants or people who don't work in science at all, which doesn't mean they're not all equally intelligent, but it just means they don't all have that shared language. So you really need to think about how to frame your message so that it's accessible for your audience. All right, so I'm talking a lot about message and audience and framing. I actually want to give you a little assignment here, put you to work and give you a chance to start practicing with crafting your message and framing it. And so what I'm going to ask you to do, and I've sort of given you an advanced warning here that I was going to ask you to think about this, but I'd like you to think about what your message is about the research that you're doing, right? How would you summarize your research in a single sentence? But I want you to frame that for different levels, for different audiences, okay? So I'm going to ask you to actually write 3 sentences. The first sentence is a 1-sentence summary of your research for someone who you're going to meet at a scientific conference, right? Someone who has a similar science background to you, maybe even has more of a science background than you do, and really has some expertise in science. So how would you summarize in 1 sentence what you do when speaking to that person? The next level is a peer. So someone your age, if you're a high school student, someone in your grade level, if you're a college student or a graduate student, someone at your level in college as an undergrad or a grad student, but someone who specifically doesn't study science at all, right? So, someone with the same age as you, same level of experience, but not with science in particular. And then the third sentence I want you to write is for a 7-year-old child. So you get asked to talk to a classroom full of second graders. How are you going to summarize in one sentence what it is that you do with your research? All right, so I want to give you a few minutes to think about that and to jot down some sentences really quickly, those 3 sentences where you just explain what you do, explain your message in a single sentence for each of these levels. And then we're gonna actually put you in small groups, and we're gonna give you a chance to sort of share out with each other. So hopefully that's clear what I'm asking you to do. If anyone has any questions about what I'm asking you to do, feel free to raise your hand now or put the question in chat. But otherwise, I'm going to give you about 4 or 5 minutes. Should be enough time to come up with your 3 sentences. And this is not a graded assignment, so don't stress out about it. It doesn't have to be perfect, but do your best to come up with those 3 sentences. And then we're going to put you in breakout rooms in groups of 3. And before we do that, I'm going to give you a little bit more of an instruction of what I want you to do in the breakout room. But go ahead and take a few minutes and work on those sentences now. And again, if you have questions, put them in chat, and I'll be happy to answer them in chat. All right, we'll give you another about 2 minutes to finish up your 3 sentences. Okay, I think that's probably enough time. Hopefully you all had a chance to come up with 3 sentences. If you didn't finish all 3, don't worry about it. Hopefully at least you got a couple down. Here's what I'd like to do. Now that you've summarized your message in these 3 different sentences, at these 3 different levels, I'm gonna ask Janelle to send you all off to breakout rooms where you'll be in groups of 2 or 3. And what I want you to do is I want you to, it doesn't matter who goes first, just sort of introduce yourselves and then decide who's gonna go first. I want you, without any introduction, I don't want you to give any background on what you do. I just want you to pick one of your 3 sentences. But here's the trick. I don't want you to tell the person or the people that you're speaking with which level you're reading, okay? Just pick one of them, whichever one you want to start with, read that sentence to them, and see if the people you're talking to can guess which level you were writing for, okay? That will let you know if you did a good job of framing it at the right level. So once you do that, then you can read the other 2 sentences and they can see if they can guess those as well. And then I want you to switch, and whoever was guessing is now going to pick their sentence. Again, don't tell people which level. Just pick a sentence and read it off and see if the people you're speaking with can guess the appropriate level. So it's just a way of sort of testing how well you framed the message for the right level of audience. So if that's clear, then I'll go ahead and ask Janelle to send you off to your breakout rooms, and we'll give you about 4 minutes to do this. So keep an eye on the time, and I want to make sure that everyone in the breakout room gets a chance to read their sentences. So about 4 minutes, have fun with this, and then we'll see you on the other side. Janelle, whenever you're ready, that would be great. Thank you.
Yep. I was moving you to back because it added everyone, and I'm moving someone over to another room.
I went to the room you invited me to because I want to make sure there was at least a couple people there, and there was only one person. So, but
Yeah, I just moved someone in there, and then I think the other person left. So I'm trying to move more people around.
Okay.
Okay, I'm moving someone to room 2. Okay. Okay, there we go. So room 1 has 2, room 2 has 2, room 3 has 2, room 4 has 2, 5, 6 has 3. Oh, I guess Vanessa's talking with someone. So, okay, as soon as it said, my camera on, as soon as it said to go into the small room, some folks left.
And you've got 2 folks in the 2 students in the main room.
Yeah, I did move them and they haven't joined. So I need, yeah, so let me send a message.
The one that's Anuj Bora was the person I was in a room with, and he was having trouble with his audio. He could hear me, but I couldn't hear him. So he's
Okay,
Anuj, I assume you can hear us now, but he doesn't seem to be able to make his audio work. So that's probably, I just told him to come back to the main room since I couldn't hear him anyway. So,
okay.
and perhaps Ayushi has stepped away from their computer right now, which is maybe,
Probably.
so.
Yeah, I just sent Ayushi a message.
It's been a few minutes anyway. I'm probably going to pull him back pretty quickly here. I'll give him another minute or so.
Okay, I'll send them a message if they have 1 more minute.
Okay, and I think if I close all rooms, it gives them a minute, right?
It does,
Well, no,
unless you've disabled that, Janelle, did you disable it?
what, close all rooms?
Yeah,
Yeah.
that's the default setting.
That should give them a minute. So
Yeah.
we can go ahead and do that now. I
Yeah.
think.
It starts the countdown, 60
Yep.
seconds.
There we go. Okay.
Yeah.
And it looks like I need to reshare my screen. So.
Hello.
Yes.
I think I missed the button to click to go into the breakout sessions.
Right.
get-
Yeah, we're pulling everyone back now. We invited you and we could see that you weren't accepting. We thought maybe you had stepped away from your computer or something, but we're pulling everyone back now. So yeah, unfortunately you weren't able to participate in that one, but we'll have another breakout session where you can participate.
Alrighty, thank you.
Okay. All right, do we have everyone back? Looks like
I don't see everyone back, Jory. I'm still seeing a few people. Well, we have, I don't know. Let me double check on the participants. Janelle, maybe you can
We
determine.
lost 4. So
Like
we
dropped
lost
out
a
of the
few
meeting.
people.
Okay, all right, well, we'll go ahead with who we have. So, all right, hopefully you all had a chance to do that activity in the breakout room to read your sentences. I would love to hear from a couple of you if anybody's willing to turn on their camera, unmute, and share the experience. How did it go? Were you able to guess the right level for your partner? Was your partner able to guess the right level for you? Does anybody feel like they would like to share out with us how that experience went for them? I'm looking for virtual raised hands here. Any volunteers? Yes, Aniket, I hope I'm saying your name right.
Yeah, you got it right. So
Great.
one thing that I noticed, it was quite easy to tell because the number of scientific words that you used and pretty much how long the sentence was. From that, you could tell that what level it was.
Absolutely interesting. And that's a very common observation, actually. So I'm glad you noticed that. I'm guessing a lot of you that are on this call had that same experience and noticed that the sentences tend to get shorter as you go from level 1 to level 2 to level 3. Thank you for sharing that, Aniket. There was another hand that was up. Who was the other person who raised their hand? Mabel, yes.
Yeah, sorry, my camera doesn't seem to be working right now.
That's okay, we can hear you.
Yeah, so our group did pretty good in guessing. We kind of just read through all of ours and guess. I think personally, I thought level 2 would be kind of harder to identify because level 3 is like the most basic pretty much. But then between level 1 and 2, it's like, I guess the only really big difference is in level 1, the words you're using are probably more advanced compared to level 2, but the way you phrase and structure the sentence could be similar. And that's just one thing I noticed.
Yeah, absolutely. Thank you, Mabel, for sharing those comments. And actually, Janelle, this would be a great point if we can allow people to put their responses in chat. I always ask this question, and Mabel set this up perfectly. So I think we're going to enable it so that all of you can share your responses and everyone will see them in chat. And what I want to ask you all is, following up on Mabel's point, I'd like to know which level was the most challenging for you to write. Which one felt like it was the most difficult for you to write? So was it level 1, someone at a science conference, level 2, a peer who doesn't study science, or level 3, a 7-year-old child? So go ahead, if you would, and just type 1, 2, or 3 into chat, and let's see what people say, because that's always really interesting to me. So 3, a couple of responses so far, agreeing 3. So far, it's looking like the consensus is 3. There's a 2, couple 2s, mostly 3s and 2s. Interesting. Thank you for sharing this. So I will tell you, I've done this activity, dozens, maybe hundreds of times, and I always see the same basic results, which is that it's always some mixture of level 2 and level 3. I almost never see anyone saying that talking to someone who has the same vocabulary as them, the same level of understanding, I almost never see people say that's the most difficult thing to do. And the reason for that is that this is what scientists are trained to do, is to speak to each other. But of course, talking to people who don't share that scientific vocabulary with you, and especially younger people, can be a real challenge. And so this is really typical. And I think this blend of level 2 and level 3 is just exactly what I typically see. And when I ask people why, I get very similar responses from workshop to workshop. So the people that say level 2 is the hardest, I think Mabel sort of alluded to this, is, for level 1, you can use as much technical language and as much jargon as you want to use. And for level 3, you can't use any of it, right? For a 7-year-old, you can't use a lot of jargon. And so those are sort of easy to define for some people, but figuring out that middle ground can be a real challenge for a lot of people. And so probably a lot of you who responded with level 2, you experienced that. Now for level 3, the people who said level 3 is the hardest, pretty much the reason is always just, how do you explain science concepts when you can't use any jargon and you can't assume that they have much of a science background at all? So, these are the challenges that we face with science communication. And, I think what some of you probably noticed, if you felt like you did a pretty good job of writing at the appropriate level and your partner guessed at the appropriate level, is you notice some of the things that have already been discussed, right? So one of them is to be concise. People intuitively know that when you're communicating about complex topics to a non-expert audience, that being more concise, using fewer words, is often a good strategy. And Aniket referred to this in his comments, right? And I can see this when I do these workshops in person. What I'll do is, while people are writing up their sentences, I'll literally walk around the room and look over their shoulders and look at the sentences they're writing. And it's almost always the case that level 1 is a single sentence, but it'll be 4 lines long, right? 4 or 5 lines long. Level 2 will be fewer, and level 3 will be a single sentence, but it'll be 4 or 5 words long, right? And that's just very common, that when you're speaking to non-experts, one of the strategies that's really effective is to be more concise with your language, right? So that's an important point. And in the interest of not being hypocritical, that's all I will say about that point. But you get the idea. The other thing that you alluded to, I think, in your comments is the language that you use, the jargon that you use, and limiting that jargon. And so, I always ask, what is jargon? What's a definition of jargon? And I'd love, again, to invite anybody who thinks they can define jargon, who has a definition for it. Feel free and raise your hand or just unmute and let us know how you would define jargon. What does that word mean to you? Anybody want to share? Yes, Ayushi, I hope I'm saying that right.
Yeah, so I would classify jargon as, in general, I guess it would be specialized language, but I think jargon would depend on who you're talking to. So if you're within the same like field, so if I was talking to other people who are also in the sciences, they would probably not consider like basic words that we consider basic words. So if I was going to talk about like in terms of biology, right? So you have the cell and the cell has organelles. There's different ones like mitochondria, cytoplasm. You mention all these words, then those probably wouldn't be jargon to someone who's also in the biology field or working in biosciences. But
Absolutely, yeah.
I was talking to like someone who's never done anything in science, then it would probably be some kind of jargon.
Absolutely. And so that's an excellent point. Thank you, Ayushi, for that comment, is that jargon is specialized language, but it also depends, as I've said already a number of times, on who your audience is. And some language will be jargon for certain audiences and not for other audiences. That's great. Thank you very much, Ayushi. Anyone else have another definition of jargon, another way of explaining what that means? I'll give people a chance to raise their hand if they want to share a definition. All right, well, I think Ayushi's definition was wonderful. One thing that I usually add to that definition of jargon is, a lot of people think that jargon is just very technical, or as Ayushi said, very specialized language. And that certainly is true. But an important thing to remember is that jargon can also be everyday language that's used in a discipline-specific way. So people in different disciplines, in different areas of science, for example, might use certain language that we've all heard before, but it has a unique meaning to them because they use it in a discipline-specific way. So an extreme example I like to give of that is the word law, okay? Law, everyone has heard this word, simple word, 3 letters long. But if you think about it, law actually has really different meanings for different people. So for example, if you were to ask a scientist or an engineer, what is a law? They would probably think of, the laws of thermodynamics, right? And they would probably say, well, a law is this sort of universal truth, right? This very fixed, rigid, unchanging thing that's determined based on observation of the natural world, the world around us, and measurement and collection and analysis of data. And no matter where you go, whether you're in North Carolina or California or Paris, France, the laws of thermodynamics are going to apply the same way because these are very fixed laws, very sort of well-defined, rigid laws, okay? So that's how a scientist or an engineer might define a law in the context of a scientific law, a law of thermodynamics, for example. Now, if you were to ask an attorney, what's a law? You would get a very different definition, right? They would say, oh, a law, well, a law is, it's a rule that we essentially make up as a society because we decide that things would be better if that law worked that way and if that law were in place, right? And a law, of course, can change from city to city, state to state, country to country. There's laws that we have in place here in North Carolina that may not exist in California or in Paris, France, right? So, a law has a very different meaning. And it doesn't mean that the scientists and engineers are right and the attorneys are wrong, or vice versa. It just means that they're using the same exact word in a very different way. And so when you think about jargon, again, you need to think about not just how you intend to use the word, but how your audience is used to hearing that word. And if you're speaking to a room full of attorneys and you talk about the laws of thermodynamics, you need to understand that that might have a slightly different connotation or meaning to them than it would if you were speaking to a room full of chemists, for example. So think about jargon as complex, technical, specialized language, but also everyday language used in a discipline-specific way. In other words, you need to always be thinking about your audience and how they're used to hearing and interpreting that word. okay? And I have a sort of I think an amusing example of the difference between everyday language and jargon, okay? And so you may recognize this. It's in the opening sentence of the great Charles Dickens classic novel, A Tale of Two Cities. And the opening line, it was the best of times, it was the worst of times. Many of you probably read this or heard this line before, sometimes referred to by people in literature as one of the great opening lines of any book in any novel ever. Very beautiful prose, right? Beautiful writing. It was the best of times, it was the worst of times. Well, what's the jargon equivalent of this? It might be something like this. The times were high variance, an analysis of cities with an N of 2, right? So that's just two very different ways of saying the same thing. And I always like to point out, I have two kids. I have a daughter who's in law school and a son who's an engineer. And I guarantee you, if I asked my kids, which one do you like better? My daughter would say, oh, the first one, Dickens, classic novel, beautiful prose. And my son, the engineer, would say, well, but the second one's actually much more, accurate and precise. So I'm going to go for the second one. And again, it doesn't mean that one is right and one is wrong. It doesn't mean, that I love my daughter any more than my son or vice versa. I love them both equally, but they just have different ways of looking at the world. And so when I saw this, I thought this is just a wonderful illustration of the difference between jargon and prose. All right, so I want to do a little bit more audience participation here. And I'm going to invite you to do this again in chat. So Janelle, if we could make the chat available to everyone. What I'm going to do is I'm going to present you with some really jargony terms or phrases, things that are said the way a scientist might say them when talking to another scientist. And what I want you to do is I want you to translate them to everyday language that you might use with a non-expert, okay? So let me give you the first example. A scientist would probably say something like, to conduct a study that will help determine. That's a very sciencey way of talking, right, of speaking. So if you were speaking to a non-scientist, how might you say this in much more simple, concise, accessible language? Does anybody have any ideas? And feel free to put that in chat and share how you would translate to conduct a study that will help determine. Let's see what you can come up with in chat. A study that shows, great. Mabel, thank you for that. Others, an experiment that will help us find, great. Simpler language. Let's try to be as concise as we can be. How would you shorten that too? Anyone else? An experiment that helps show, great, thank you. Good contribution. How about this? How about if we just say, there we go, to find out how we're going to run some tests? Great, everyday language. If we want to be really concise, how about just saying to study, right? That's what we're doing. Why use 8 words when you can use 2, right? But yeah, you get the idea. You've all done a really nice job of putting it in more accessible language. Okay, let's do another one. This is a very sciencey sounding phrase. We elucidated the mechanisms by which. So how would you say that in everyday accessible language? Anyone? Shown how? Great. Others? Anyone else have any? Explain the ways? Great. Yeah, these are great. You're doing a really nice job here. I came up with showed how. Again, 2 words, right? Keep it simple. Explained how, showed how, great. Yeah. So you get the idea, right? It's about using simple, accessible language. Here's one. This is an example. You see this kind of phrasing all the time. People will say things like, foster interdisciplinary collaborations, right? A lot of polysyllabic words. And by polysyllabic, of course, I mean words with lots of syllables, such as polysyllabic, right? But what are we really doing when we say we're going to foster interdisciplinary collaborations? It's a much simpler way to say that. Anybody? Work across fields, great. Work together, exactly. Yeah, so I would just say work together, build teams, work across teams, related several topics, great, yeah. So again, it's about using simpler, more concise language. And what I always like to point out is that science communication is not about convincing people that you're really smart, okay? You're obviously all really smart. You're all students that are doing scientific research, and you're going to be presenting it at a scientific conference in a few weeks, right? You don't need to work hard to convince people that you're smart. People already know that. You've won that battle, right? The goal, as I've said already a number of times, is to help people understand what you do and why it matters to them. That's the goal of communicating science. It's not to convince them you're smart. They already think you're smart. It's to help them understand what you do and why it matters to them. And so all of that language on the left side of the screen might sound very fancy, right? But if people don't understand what you're saying, then you're not doing an effective job of communicating. And so using language that you see on the right side of the screen is much more concise and accessible. And this is how you effectively communicate what you do and why it matters. All right, there's a very specialized kind of jargon that I want to mention, and that's what I call number jargon. And so this is jargon in the form of numbers. So as scientists, as engineers, we love our numbers. We're very quantitative. We're all about numbers, right? We're actually rewarded for, it's our currency. We're rewarded for using lots of numbers. But numbers can be jargon too. And so let me give you an example. You know, a scientist might say something like 48.95% with a p-value of less than 0.0532. All right, that's a very numerical way of saying that. But when you're talking to someone who's a non-expert, what's a better way of saying that same thing? What's a much more accessible way of saying that? Anyone have any thoughts? Go ahead and put it in about 49%. Okay, let's be even more general than that if you can. And some of you, by the way, are putting your comments, you're sending them in direct messages. Feel free to copy that to everyone so everyone can see your responses if you want. Yeah, half, or, you know, what did I have? I had about half, about half, right? Now, is half or about half, is that as accurate and precise as 48.95%? Of course it's not, but around 50, there you go. Great, yeah. But about half is good enough. When you're speaking to people who don't need that level of precision, about half conveys the message perfectly well. And the reality is that we all know that if you repeated that experiment 1,000 times, you're never going to get 48.95% again anyway, right? You're going to get 49.32% or 50.07%, right? So do you really need that level of precision with people who just want the general message? And generally the answer is no. About half is perfectly fine. Or how about this? 32 million Americans. People give numbers like millions and billions all the time. It's really hard for anyone to wrap their head around 32 million of anything. So how would you say that in a way that's more accessible? And I'll give you a little hint here in case you don't know. There's about 320 million people in America. So yeah, around 1/10 of Americans, great. Any other ideas, any other suggestions? Millions of Americans, yeah, that's another way of saying it. See if there's any other suggestions. 1 in 10 Americans, great. And I think that's exactly what I had, 1 in 10 Americans, yeah. So, you know, people can't picture 32 million of anything, but people can picture 10 people in a room and imagining one of them, I don't know, had the Delta variant of COVID. Whatever example you want to give, right? It's much easier to picture 10 people in a room and imagine one of those people than to try to wrap your head around 32 million, okay? So again, it's simple, accessible language. It's helping people visualize and understand the numbers you're talking about. Here's one more example. You see this all the time. People will say things like, the largest dinosaurs had brains about 8 centimeters in diameter, all right? Well, first of all, this is America, so nobody really is familiar with the metric system here anyway. Most of us don't use it. I mean, if you live in another country or grew up in another country, you might be familiar with centimeters, but most people born and raised in the US aren't particularly familiar with centimeters anyway. So how would you convey the idea of the size of a dinosaur brain in a more accessible way than 8 centimeters? Anyone have any thoughts on that one? Let's see what you got. Oh, that's great. Big dinosaurs had tiny brains. If you wanted to give them a sense of how tiny, how might you say that? Any other ideas? These are great suggestions so far. The size of an orange, great. Yeah, absolutely. And so, my answer that I usually give is about the size of a baseball, right? But a baseball and an orange are about the same size. But, you could even make the argument, well, if you live in a place that doesn't have, where they don't grow oranges, maybe someone's never seen an orange before, maybe that doesn't mean anything to them. Or, maybe you live in a country where they don't play baseball very often, and so that won't really have much meaning to them. So if you really wanted to be universal in this, you might say something like the average dinosaur had a brain about the size of your fist, right? Because that's about the same size as an orange or a baseball. It's about 8 centimeters. And as it turns out, everyone pretty much has a fist, no matter where you are, no matter what sports they play or what fruit you eat. So the point is, again, it's about not asking people to do math in their head, but asking them to just simply picture something that they can relate to and using accessible language to help them understand and to help them see exactly what concept you're trying to illustrate. So these are ways to think about sort of trimming out some of the jargon and using more accessible language to help people understand what it is you do and why it matters to them. Another strategy that's really effective for helping cut through some of the jargon is to use things like metaphors and similes, okay? So metaphors, similes, you probably have studied these before, in your literature, your composition, your English courses, right? These are designed, their whole purpose is to help people understand complex ideas using simple, accessible language. And so in science, one of the classic metaphors is, and I'll give you an illustration of the difference between metaphors and similes, but one of the classic metaphors that I'm guessing most of you have heard before involves the mitochondrion. So what's the metaphor that pops into your head immediately? And put it in chat. I invite you to put it in chat. When you hear the mitochondrion is the, exactly, powerhouse of the cell. How many of you thought powerhouse of the cell immediately, right? We're almost programmed. We hear mitochondrion is our brain fills it in with powerhouse of the cell. Now, I would argue that maybe that's not even a great metaphor, because for most people, what is a powerhouse? What does that really mean? I mean, if you don't happen to live near some sort of steam plant or coal plant, you might not really have a good sense of what a powerhouse is. But nonetheless, most people, when they hear mitochondrion, they think powerhouse of the cell. And it gives them at least some sense that it involves producing energy, right? So that's a metaphor, and it's a very good way of helping people understand a complex idea that they might not be familiar with. And I mentioned similes. Similes are very similar to metaphors. The difference is that a metaphor is literally saying this is that. The mitochondrion is the powerhouse of the cell. Whereas a simile, it's the same concept, but it uses the word like, okay? So as an example, my training as a scientist is in the field of immunology. And so when I would describe to people the immune system, I would say the immune system is like the police force of the body. And the T cells and B cells and macrophages are like the cops, and the viruses and bacteria are like the criminals, and the T cells and B cells roam around and try to, control or put a limit on the viruses and bacteria. And, it's a simile, but it's the same concept. It's explaining a term or a concept that might be foreign to people, but explaining it using something that is accessible and understandable to them. So a really effective way to communicate your science to people who aren't experts and don't have a shared vocabulary is to use a metaphor or a simile. So I encourage all of you to spend some time thinking up that metaphor or simile, which is sort of the perfect way to explain what it is that you do in research. And it may take a while to do. It's not always easy to come up with a good metaphor or simile. But once you do, you want to hang on to that. Just keep it in your back pocket, because you never know when you might want to pull it out. You might be talking to friends or family. You might be, I don't know, taking an Uber ride and the Uber driver asks you what it is that you do. Who knows? But if you have that metaphor ready to go, it's always a great way to explain to people what it is that you do. All right. I want to say just a couple more things about jargon, and then we're going to move on to some other concepts. And I think we'll take a quick break here soon if you need to take a bio break or get a drink of water or something. But before we do, I just wanted to say one more thing about jargon, which is that part of the problem with scientists and jargon is that I really think that most of the time, scientists are so used to using jargon every day that they don't realize how much of what they say in their everyday language actually is jargon to most people. And so there's some tools out there that can help you sort of identify how much of your language is actually jargon. One of them, as you can see on the screen, is called the dejargonizer. And you can access this, anybody can access it for free at scienceandpublic.com. And it's a really simple text editor where you can put in any text, and it has an algorithm that determines how frequently each word of text is used in everyday speech. And if it's not frequently used, then it's determined to be jargon. And so to give you an example of how this works, I thought to myself, if you had asked me, if you had said 30 years ago, hey, Jory, what do you do as an immunologist? And this was before I ever had any sort of science communication training. I probably would have answered that question by saying the following. And you can read this sentence for yourself, and you can see how it's just, very loaded with jargon sentence. This is what I did, and this is how I probably would have answered the question 30 years ago. And if you put this into the dejargonizer and you click start, what comes back is a sentence where almost every single word is in red or orange, meaning it's identified as jargon, as language that's not commonly used in everyday speech. The words that are not in red or orange, are pretty simple language. I, in, to, of, the. I would even argue that investigate is jargony because there's a simpler way to say investigate, which is I study, right? But this is just a way of showing you how much of my everyday language back when I was in the research lab was just really jargon heavy language. And so I decided, okay, I'm going to change this, and I'm going to come up with a version of this where I have no more red or orange words. And so I changed it a bit, and I hit start again, and there were fewer red and orange words, but there were still some, and I tried it again, and it took me 4 or 5 trials before I eventually came up with this sentence. I study a change in small animals, which makes them get sick because some bad cells in their body don't die when they should. Now, this is very simple language, and as you can see, none of these are highlighted as red or orange. None of them are identified as jargon. Is this very simplistic language? Absolutely. Would a middle schooler understand this better than they would understand this? Almost certainly, right? So what I challenge you to do is I challenge you to go to scienceandpublic.com and open up the dejargonizer and take those 3 sentences that I had you write earlier and throw them into the dejargonizer. And what you should see is that level 1 should be loaded with red and orange words. And level 2 should have fewer. And if you did a really good job, your level 3 sentence should have no red or orange words at all. And again, this is just a way for you to get a sense of how much of your language might be jargon to people who don't work in your field. So just sort of a fun way to play around with that. So, all right, we're about an hour into our 2-hour workshop, and I want to give everyone a chance to get up, stretch their legs, use the restroom if they need to, grab a drink of water if they need to. So it's 2:04 where I am, and so I'm going to give you 3 minutes. Hopefully that's enough time. Take a break, do what you need to do, and in 3 minutes, let's be back here and get ready for part 2. And I'm happy to stick around if people have questions, they want to put them in chat or just unmute and ask questions. I'm happy to answer questions during the break. All right, so that was your 3-minute break. Hopefully that was enough time to take care of business. What I'd like to do is jump back in. So if you're working your way back to your computer, welcome back. And again, I would love to encourage people, if they're willing, to turn their cameras on. It's always great to see people's faces. I know not all of you can necessarily turn cameras on, or maybe your camera's not working, but if you're willing, it's always nice to see people's faces. And what I want to do now is I'd like to move on from jargon. Hopefully you got the message. Let's try to avoid it as much as we can. The last thing I'll say about it, though, is that, sometimes you have to use jargon. There's no way around it. I mean, it's sometimes hard to tell people what you do without introducing a term or two. But, just think about how you can keep it to a minimum when possible. Okay. Moving on from jargon, I want to talk about a few other strategies that are really effective for helping people understand what you do and why it matters to them. And you can probably guess from this next image what I'm about to discuss, which is the importance of storytelling. All right. So just as a quick challenge, I'd like to ask each of you to just take a few seconds and think about in your own head, think of a story that you really loved when you were a kid. It could be a book, it could be a movie or a video that you watched over and over. I always like to hear about books because I'm a big reader. And so, think about maybe your favorite book when you were a little kid, that book that maybe you asked your parents to read you every single night before bed. What stands out about that book? Why is that the first book that popped into your head when I asked you this question? What did you love about it? What made it memorable? And what elements do you still remember to this day? And we don't really have time to hear from each of you, but I do want to encourage you to feel free. I would love to just invite you to put in chat the name of the story, the book, or the movie that you loved as a kid, just because I always enjoy seeing people's responses to this. So feel free to put that in there into chat, and I'm sure everyone else would be interested to see what story, what book, what movie was kind of your favorite story as you were a kid growing up. But as you're thinking about that story and thinking about why you loved it and what made it memorable, I want to, make a point, and I'm sort of looking at these as they go, as they appear. My kids loved the movie Rio. I liked watching that one with them. But what are the elements of what stands out to you? What do you remember about this story, this movie, this book that stands out, right? And usually it's some combination of the following things, right? You remember the story itself. You remember the plot. You remember essentially what's called the narrative arc. What happened, right? What happened in the movie? What happened in the book? But you also remember other things. Typically, you'll remember images. There'll be, whether it was a movie and it was something you saw, or whether it was a book and it was an image you created in your own head. You remember the conflict, that what happened that created suspense or mystery in the story, right? Because pretty much every great story has some sort of conflict, some sort of mystery. You obviously remember certain characters, they stand out in your head, and the emotion, the way that it made you feel. So these are the elements of a good story. And you may also remember, maybe recently, maybe a long time ago, talking about the story diagram, right? Which is sort of the visual representation of what happens in a story. And, just as an example here, we look at Cinderella, which is a story that almost everybody knows. And, it starts out with what they call the exposition, which is where they just introduce the characters and introduce the setting. And then something happens and some conflict arises. And then, there's some resolution, but then maybe another conflict happens. And there's sort of this whole arc that's followed by the story, right? And so this is how we would diagram a typical story. These are the elements of what makes a story memorable, okay? So why am I talking about this in the context of science communication? Well, it turns out that science storytelling, it's a really effective way to communicate what you do, right? So often scientists are told by other scientists, don't tell a story, don't use anecdotes. It's not about individual examples or anecdotes. It's about the data, right? The data in the aggregate, large numbers of data. these are what matter to communicating science. But what I'm telling you is that when you're communicating about your work to non-experts, to people that aren't other scientists, that storytelling is actually the most effective way to communicate meaning and purpose, right? And the reason is based on everything we know about what happens in your brain when you hear stories. People have studied this, and we now have lots of data and lots of understanding of what's happening biochemically and at the neuronal level when people hear new information in the context of a story, right? So as a scientist, you can simply put up a slide with data, with numbers, with graphs, and not tell any story and just say, well, the data will speak for themselves. But what we know is that if you introduce that same exact information in the context of a story, if you illustrate it in the form of a story, several things happen in your audience's brains. What we see is we see a spike in something called cortisol, which you may be familiar with. It's a hormone that's associated with the fight or flight response. And as a result, it's known to, among other things, focus attention. So when people hear a story, they get these cortisol spikes and they pay more attention to what's being said. We also see a spike in something called oxytocin, which is a hormone that's present in mothers that have just given birth. It's sometimes called the empathy hormone because it's shown to make people be more involved, more emotionally invested, more caring about what's happening. And so if you tell people about your science in the context of a story, they're not only going to pay closer attention, but they're gonna get this oxytocin spike that will make them care more. We see a spike in dopamine, which is a neurotransmitter that, among other things, aids memory. So it helps people remember what you're saying. And remember earlier, I talked about your message. And I said that one of the things that's really important is that it's memorable, that people can remember what you say. And so dopamine helps with that. We also see an increase in neural coupling, which is simply new connections being made in the brain. So all of these things combine to allow an audience member to pay closer attention, to care more, to remember better, all of the things that you're telling them. So when I say tell a story to help people understand your science, it's not just because that seems like it would be a better way to do it. We actually know what's happening in the brain that demonstrates that this is a more effective way to communicate about your science, all right? And so what we know from all these studies is that storytelling does a bunch of things for you. It increases your audience's engagement, comprehension, and retention. And those are jargony words, so let me say it a different way. Storytelling increases your audience's ability to pay attention, to understand, and to remember what you're saying. And those are really good things when you're talking about your science. It helps them take all of this complex information you're introducing and gives them a framework for organizing it. This is one of the things that storytelling does. Storytelling also helps your audience connect the information with their everyday life. And remember what I've been saying over and over, it's about helping them understand what you do and why it matters to them. Storytelling allows them to make that connection to their life. And finally, storytelling has a known effect of being more persuasive. So it compels people to act in specific ways. So if, for example, you're doing, climate change research, and it's really important for you to communicate to people that they should or shouldn't do a certain thing, use fewer fossil fuels, for example. If you just give them the data and the numbers, that won't be very compelling. But if you can tell them a story about an individual who lives in a place where they've reduced fossil fuels, and now that individual is showing, fewer asthma attacks every year because the air they're breathing in is healthier, that has more meaning to them. And it's going to make people understand, and they're going to behave differently because you've illustrated it with a story. So think about the importance of using stories and the effect of using stories to communicate your science. And to help you do that, I have another brief activity that I want to do that I think will be really fun and sort of builds on the past activity. And it involves something that is called the ABT template. And this ABT template is just a very simple template for helping you tell a story about your science in just 3 sentences. So again, I'm going to ask you to write 3 sentences, but it's a little bit different this time. ABT stands for and, but, and therefore. And so you're going to have 1 sentence with and, 1 sentence with but, and 1 sentence with therefore. The and sentence is what I referred to earlier as the exposition, sort of giving people the facts or the information they need to know. Then we talked about a conflict in that story diagram. The but sentence is where you introduce the conflict. And then finally, the therefore sentence is where you try to start to bring some resolution or tie things together through the word therefore. And so to give you an example, I constructed an ABT set of sentences, an ABT story, to talk about what I did as an immunologist. So I would start out with my and sentence. Our immune system protects us from foreign invaders by attacking them and destroying them and removing them from our bodies, right? So you can use as many ands as you want here to add all of the exposition, the different information you want to convey. But we've now introduced the fundamental model that we're looking at, right? The immune system and all the things that it does. Now we come to the second sentence, the but sentence, where we introduce the conflict. But if our immune system attacked our own bodies the way it attacks foreign things, this would cause all sorts of problems. So we've introduced the conflict here, the fundamental conflict, which is that the immune system can't attack itself or we get disease, we get autoimmunity. And then we try to bring some sort of tie it together with some resolution with our final sentence, our therefore sentence. Therefore, I studied how the immune system could tell the difference between foreign and self. Okay, so in 3 very simple sentences, following this very straightforward template, I told the story of the research that I did. Now, I didn't explain all of the findings that I got, but I at least explained what I do, what the conflict is that I study, and why I'm studying it, and how I'm trying to get answers or resolution. So, as you might guess, I'm going to ask you to write a story about your research using the ABT template. All right, so again, I want to give you about 3 or 4 minutes. It shouldn't take long at all to come up with your 3 sentences. And I'll put this back on the screen just so you have this as an example. So take about 3 or 4 minutes and write down your ABT sentences. And then we're going to do the same thing, which is we're going to put you in breakout rooms just for a few minutes. And we're going to have you read your ABT sentences to your partner and give each other some quick feedback on that. So go ahead and work on your ABT sentences now. If you have questions, put them in chat or just unmute and ask the question, and I'll be here to answer your questions. I'll give you a few more minutes, but I think I just want to make a quick announcement, which is since the breakout rooms, a few of you had some problems, some of you couldn't get your audio to work correctly. I think maybe we'll skip the breakout rooms And instead, what I'm going to invite you all to do is once you've written your 3 sentences, your ABT sentences, I just want to encourage you, invite you to post them in the chat and share them with people, because I would love to see, this way we can all see everybody's sentences. The chat's open for everyone, so go ahead, we'll give you a couple more minutes, work on your ABT sentences, and then when you're done, please feel free to share them and we'll see what you come up with. All right, we'll give you 1 more minute, and then, as I said, feel free to put them in there. Akshat has already shared his, and it was fantastic. So I encourage you all to share yours. I'm sure they're all going to be just as good as Akshat's, but that was really wonderful. Give you another minute or so to finish up and post it. Mikul, I hope I'm pronouncing that right. That's wonderful, really, really great, really clear. No real jargon in there. And very obvious to us why we should care about that, right? Very relatable. Good job. Wait another minute or so, get a few more posted. Okay, there's another one. Wow, fantastic job, Carolina. And I'd love to know more about that machine. That sounds really interesting. I'll have to attend your research presentation to learn more about it. You guys, these are fantastic. You are all you're knocking it out of the park. Keep posting them because I'm really enjoying these. And hopefully we can save this chat because I might not be able to read all of them now, but you're all doing a really nice job from what I can see. You're all doing a great job of avoiding jargon. You're doing a great job of communicating relevance. I'm curious if anybody wants to share. I'm curious to hear from 1 or 2 of you if you want to unmute and just share with us, what are your thoughts on this template as a way of helping you summarize and tell the story of what you do? Does anybody have any thoughts on this? Anybody want to share what they think? Yeah, Yushi.
I think this template is nice because you can kind of give a very simple background, explain what the importance is, and then explain what you did in just, a few seconds. If you were to say this out loud, it might take, 10 to 30 seconds for you to say this. And I think it would make it extremely clear in the beginning of your presentation to someone who's watching, even if they're not particularly in the science field.
Yeah, absolutely. I agree. And, one of the things I like about it is that the template, I think, is so well designed. And by the way, I should have said this at the beginning. I didn't come up with this ABT template. I can't claim any credit for it. but I think it's so well designed that it almost does all the work for you, right? All you have to do is follow along with the template, and it makes it so easy for you to tell the story. And if you just remember, to try to avoid jargon, it's a really simple, easy way to tell the story of what you do in just 3 sentences. Well, this is great. I'm really impressed. I really love what you've all come up with. And again, I'm hoping we can pull the chat transcript, because I want to make sure I have time to read through all of these. But from what I'm seeing, you're all doing a great job. So kudos to you, and hopefully you'll think, this helps you think about how you would communicate your work more effectively using a storytelling template, and why you would want to do that now that you understand a little bit more about the biochemistry and the neuroscience behind what happens to people's brains when they hear information in the context of a story. All right, so storytelling, an important component of science communication. But I do want to, in the last half hour or so that we have, I want to share with you a few more tips for really effectively communicating what you do. And then before we wrap up, I'm also going to share a few tips on effective presentation of your information. All right, so the next simple tip is to be definitive. Be definitive when you're speaking about your work. Now, why is this important? Well, scientists have a tendency to be a bit cautious when they speak about their work and what it means. And this is partly the way that we're trained as scientists, right? People are often trained to be a bit cautious and not make, grand sweeping pronouncements or make big assumptions. And that's a good practice, but in practice, it somehow sometimes has the effect of having people seem like they're a bit non-committal about their information. And so to give you a specific example, a scientist might say something like the following. They might say, well, our data are suggestive of the possibility that there might be a correlation between factor X and result Y. And therefore, we think that there's a suggestion that it might be possible. This is typical science speak, right? And they might go on to say things like, we're not convinced of the statistical significance of the work because our sample size was too small, so we're going to repeat it with larger trials and larger sample sizes, and we'll do different statistical analyses. And you get the idea, right? Scientists have this way of qualifying a lot of what they say so that it doesn't sound like they're being too committed to any definitive statement. And again, we understand why this is, because you don't want to make these grand sweeping pronouncements that might be misleading. But at the same time, when scientists speak that way, it's very frustrating for the public, for non-experts. Because when a non-expert looks to you as a scientist, they want information, they want answers. They're looking to you as an expert to give them answers, right? So if someone asks a scientist, should we wear a mask in public when we're outdoors? Is it going to protect us? Is it necessary? They don't want to hear your answer about how many trials you did, or how many, what the sample size of people studied in the trials was, or what statistical package you used to analyze the results. They just want to know, yes or no. And so to the extent that you can give a definitive answer, a yes or no answer, that's always the best practice. Now, again, there isn't always a yes or no answer. For COVID, for example, there's still a ton of things we don't know about COVID yet. So you might not always have a yes or no answer. But again, be as definitive as you can and say, well, we think that, yeah, all the data suggests that masks do help. So, you should wear masks. And, be as definitive as that. I mean, we now have pretty good data to show that masks do help in most situations. So, so say what we know about it. Never make up information, obviously, but to the extent that you can be definitive, people really appreciate that. The last thing I'll say about that is, that you want to be definitive, but sometimes the best answer is, we don't know. And that's perfectly okay. If you don't know, then the best answer is, great question. We don't know. We're still looking at it. We'll have answers for you soon, you know? But you can leave it at that. You don't need to go into lots of detail about why you don't know yet, because that's not really going to be helpful to most non-experts. So bottom line, when you can, be as definitive as possible in your answers, because you are the expert on your science and people are looking to you for your expertise. The next piece of advice or suggestion that I have is to use statistics. Statistics are a really powerful way to communicate information about science, right? Statistics represent these sort of little nuggets of information that illustrate or give examples of the meaning of what you're doing. And they're very compact and portable, which means that people can often hang on to that statistic. And when they're talking about your work later, that statistic helps them illustrate the meaning of the work that you do. So statistics can be really powerful and really effective in communicating your work. What I will say about statistics, though, is like anything else, you want to use them in moderation. If you're giving a 10-minute talk and you cite 43 statistics for 43 different things in 10 minutes, that's probably too many statistics. But in a 10-minute talk, you know, 2 or 3 maybe really, you know, good examples illustrated by statistics could be a really powerful, effective way to illustrate what you're doing. And a colleague of mine, whenever he talks about this, he always says, and I'm going to lay a simile on you here. So remember, this is going to have the word like in it. But he says, statistics are like seasonings in the kitchen. If you use too much, you can ruin the dish. If you don't use enough, it might not really have the same impact. But if you use just the right amount, it really enhances what you're doing, right? And so, you know, statistics, when you're using them effectively and you're not overdoing it, are a really powerful way to communicate. So think about using statistics to illustrate your point. The next thing is to think about, when possible, how you can use either drama or humor as a way of emphasizing or explaining your message to your audience, right? So drama can be really powerful, really compelling, right? If you're talking about, you know, about COVID and you give examples of, you know, how many, you know, we hear statistics all the time about how many people have died, over 700,000 people in this country, right? You can tell the stories of individuals who've lost family members. This is very dramatic, it's very powerful. Now, again, you don't want to overdo this because the goal is not to depress people, but, you know, used in moderation, drama can be a very powerful tool for helping communicate the meaning of your work. Similarly, humor can be very effective if it's used effectively. But a couple things to keep in mind about trying to use humor to communicate your research or your science. One is that, you know, some things are just not funny. I mean, there's no way to talk about 700,000 deaths from COVID in this country and make a joke out of that. It's just, it's not a funny topic. And if you try to make a joke about that, I guarantee you it's not going to work. It's not going to enhance your message. So, you know, use it when it's appropriate, but don't use it when it's not appropriate. And related to that, the other point is, you know, that with humor, you need to be cautious, because when it works, it can work really well. But when it backfires, it can backfire spectacularly, right? So if you try to make a joke and it doesn't go over, you're going to do much more harm than good. And finally, humor is only humorous when you're not targeting someone, right? A little self-deprecating humor can be okay, but if you're trying to make a joke at someone else's expense, that's just not funny. And it's certainly not a good way to illustrate or to communicate your science. But again, when done well and done in moderation, both drama and humor can be really effective ways to communicate your message to people. Related to that, another really effective way to grab your audience's attention and to get them to listen to what you have to say is to hook them or grab them with something that's surprising or something counterintuitive, something, you know, again, a statistic, for example, that they wouldn't have imagined, but it's really powerful when they hear it. And often if you use this as your opening line, then it's extra powerful, right? So, you know, I have my students who take my course, my science communication course, I have them develop a sort of a mini TED Talk, and they deliver mini TED Talks in class. And one of my students studied malaria, which has been in the news a lot lately because they just have announced that they're going to be distributing this new malaria vaccine around Africa. It's a really big deal. They've been trying for ages to develop a malaria vaccine. One of my students, a graduate student a few years ago, she studied malaria, and her opening line of her TED Talk was, in the 7 minutes that I'm talking to you today, you know, 12,000 children around the world are going to die of malaria. Now, again, that's a dramatic fact, but it's very powerful. It was a surprising statistic, but it was a very powerful opening line because she grabbed our attention right at the beginning, and then we were focused on what she had to say the rest of the way. She grabbed our attention with something that was drama, it was a statistic, and it was surprising. And all of those things grabbed our her audience's attention and really made us pay attention to what she had to say. So try to use some sort of a hook that's surprising or counterintuitive to grab people's attention. And then the last tip I'll give you on this is, maybe above all else, bring passion to what you communicate to other people, right? You presumably have a passion for what it is that you do, the research that you do, a passion for science. And reading the ABT sentences that you posted, that passion showed through in a lot of them. I could see that you are really excited, you're really interested in what you're doing. You really see the value and importance of what you do. So take that passion and infuse your talk, infuse your writing, infuse your presentation, infuse your poster with the passion that you feel for the work that you're doing. Because if you convey that passion to your audience, they're going to be excited and they're going to care about it. And if you communicate somehow a lack of passion, if you somehow suggest to them that you're bored by what you do, that you don't find a passion in what you do, then you're sending the message to your audience that they shouldn't care either. But when you infuse your talk or your writing with passion, then your audience feels that passion and they understand why they should care about your work. And remember, that's the point of all of this, is to help your audience understand what you do and why it matters to them, why they should care about it. All right, so I'm going to pause there. We've got about 20 minutes left. I do have a few more things I want to talk about, things about presenting. But before I do that, I want to pause here and open it up and see if anybody has any questions about any of the things that we've covered so far, about jargon or about storytelling or about crafting your message or knowing your audience. Does anybody have any questions? Feel free to virtually raise your hand or throw the question in chat. We'll see what you got. Or just feel free to unmute as well if you want to ask a question.
What will be the type of audience that we're presenting to?
That is a great question, and I'm going to actually invite Fenella to unmute because Fenella Saunders will be able to answer that question much better than I will.
I'm happy to answer it. Janelle may also want to chime in. If you're talking about presenting at the Student Research Conference, you will be presenting both to judges and to regular audience members of the conference. So that will include professional scientists. It'll also include people who are your peers and other students, people who are attending the conference who are members of the society. So there's a wide range of people who attend this conference. Many of them will not be in the same field that you are in, which is why it's also important to understand this idea of field-specific jargon that Jory was talking about. And so Janelle, did you want to add anything else there?
Actually, Fenella, you answered it perfectly. So that's the answer.
Okay. I'm sure Janelle is the one who organizes the Student Research Conference, so she knows far better than anyone who the judges are and who attends the student presentations. But I will say, Janelle, maybe you can add here, the judges are usually selected to be at least related in their background to the field of the student, because the papers are presented by topic area, they're sort of grouped. So the judges will have some background knowledge, but not everybody attending, not everybody looking at your poster will. So you should be prepared to explain your research to people who may have sort of an interest and a background in science, but will not have any knowledge of your particular field.
Yes, that is correct. And the information will also be sent via email in the next few days. But so you know, the students, you will receive information on how to access the portal, and it's not in real time. So the judges or the students will be reviewing your presentations, not in real time, and they'll actually have a week to review. So usually when we meet in person for our student research conference, we do it over the course of one day, which would be that Saturday. But because we are a virtual format and there are so many students presenting, we will be allowing judges the opportunity to review the presentations over the course of 1 week. So you will have to have your presentations ready to go by the end of October. More details are forthcoming within the next few days.
That was a great question though, Carolina, and I appreciate you asking that because I'm sure everyone else benefited from those answers. So thanks, Janelle and Fenella, for answering that better than I could.
Right. And, you know, since the thing about it being virtual is it is a little bit different than we normally would do in an in-person conference, as Janelle was saying. In an in-person conference, you might have the opportunity to tailor what you were saying to the individual person you're talking to. But here you should be prepared because you're pre-recording for it to be viewed by anybody, not just to a specific judge. Right, Janelle?
Correct.
And one more point I want to make, and thank you for those answers. One more point I want to make about that is if you just look through the chat at the ABT sentences that everyone posted, that's a perfect illustration right there of the sort of multidisciplinarity of the work that you're doing. So as you think about how to put your information together for your presentation, you know, think about what we talked about earlier, which is that your audience, even if it's going to be an audience of other scientists, they're going to be from different disciplines. And so they're going to have a different vocabulary than the one that you use for your discipline. And, you know, when I talk about communicating to non-experts, that doesn't mean that they're not, you know, very bright, educated, intelligent people. It just means their expertise is not necessarily in your area. So as a biologist, you know, I can talk to other biologists all day long, but if I talk to a physicist, you know, I'm going to have to be a lot more careful about the language that I use because they know everything about physics, but may not have the same vocabulary that I have as a biologist. So, you know, it's really important to remember that you're speaking to these diverse audiences and you're using language that's accessible for everyone. Any other questions? That was a really good question. Thank you. Any other questions before I sort of wrap up with a few thoughts on presenting? Okay, well, there may be, again, time for a few more questions at the end if you have them, but I want to transition a little bit. Oh, sorry.
Sorry, I had one question.
Yeah, sure.
So I'm also in speech and debate, and we give a lot of, my event is informative speaking, and a lot of it, because of it's virtual now, we do a lot of videos. So we take videos of our speeches, which are like 10-minute TED Talks about any topic. I like to give mine on science. So this year I'm giving on machine learning and healthcare. And my main question for that is, if I don't know the audience and I'm doing it, I cannot see the audience since it's going to be, I'm recording a video. What are some tips you would give for that?
Yeah, no, it's a great question. And you know, I sort of addressed that earlier when I was talking about diverse audiences. You know, it's a hard, there's not a really perfect solution for that. When you don't know who the audience is going to be, or when you know it's going to be a non-homogeneous audience, or a heterogeneous audience that's made up of different people with different levels of experience. There's no simple way to use language that's accessible to everyone if they're at different levels or you don't know what level they're at. And so the best advice that I can give, and you know, Fenella and Janelle are welcome to chime in here as well, but the best advice I could give is what I said earlier, which is that in that situation, it's safer to be a bit more general and, you know, be a bit less or more focused on avoiding jargon, and you know, because that way you run less of a risk of losing people who don't have that level of understanding of the topic that you might assume with a more complex presentation. So, you know, it's always easier to respond to your audience by ratcheting up that level of conversation. If you're pre-recording it, as you said, Aniket, then obviously there's nothing you can do about that. But still, if you speak at a slightly more accessible level or layer, then you're less likely to lose people who might not be able to engage with the level of sophistication if you speak at a higher level. If you lose people at the beginning, then sort of you've lost them for good. So I think it's safer to just speak at a more accessible level and just hope that it's not at a level that's too low for your audience. But you know, when you can, try to find out in advance who the audience is going to be. But if you really don't know, it's safer to err on the side of caution and being a little bit more basic. You can, you know, perhaps add some information about where they could go to get more detail if they want it. But you know, you just need to be aware that if you don't know the audience in advance, it's safer, I think, to be a little bit more basic with your delivery of information. Fenella or Janelle, do you have anything to add to that?
Oh, yes, I do. And also there'll be an opportunity for, you know, individuals to contact you. There is a chat feature in the portal that you'll be using for the conference, and even a video function if, you know, they wanted to schedule something to meet with you to discuss your work in more details. So that is an opportunity if you wanted to share more information, more, you know, technical information, if that person that is contacting you is, you know, a judge in your area of research.
Yeah, I mean, in some ways it's always easier when you have a live audience, because I always say so much of communication is responding, you know, communication is two-way. It should be not unidirectional, but bidirectional. And you should be looking at and listening to and observing your audience and watching how they're responding and reacting to what you say. And you can often see on their face, are they understanding you? Are you losing them? Or do they look bored? And they, you know, you can actually be giving them more technical information. But of course, you lose all of that when it's a video that's pre-recorded, or if it's a talk over Zoom where everybody has their cameras off, which is why I encourage you to turn on cameras if you're willing. But this, you know, part of this is just the reality of the world we live in now, where more things are being delivered over Zoom and more things are being pre-recorded. So, you know, you do the best you can, but when you truly don't know who your audience is going to be in advance, then inherently there's going to be that challenge every time. Good question though, thank you. All right, so let's talk a little bit in the last few minutes about some strategies for presenting and visuals that will help you do a better job of communicating to your audience. All right, so I'm going to give a talk today. And each of my points will be made in a bullet, and many of them will be quite long and redundant because I'll repeat myself over and over and over. I will have many bullet points for you to read. All of them will be different sizes and fonts and colors, and some colors will be really hard to see, like this one that I've done in yellow. Some of them will fly onto the screen in annoying ways. I'm going to read each bulleted item to you word for word. You will read my bullets to the end in less than a minute. Seeing every mistake. I will keep talking for a really long time then. You will check your phones, you'll fall asleep, you'll just wish you were anywhere but here. You'll pray for me to finish. You're not going to learn much from me at all. Oh, and by the way, maybe I'll go backwards and add stuff I forgot to add. All right, this is terrible. The last 2 minutes of your life that's 2 minutes you'll never get back. And I apologize for doing that to you, but obviously I was trying to make a point there, right? You've all seen terrible talks with these horrible all text bullet point PowerPoint presentations. It's just torture, right? Don't do this, right? Less text, more visuals, always a safe rule. Avoid the sound effects and the bouncing words and the spiraling words. Don't change so that every bullet point has a different color or a different font. Just, it's about visuals and it's about being visually pleasing. Speaking of that, I also have lots of data that I'm going to share with you, and I'm going to cram it all onto one slide so that I have to make everything really small so that you can't see any of it, and none of it will have any meaning to you. You won't even be able to read most of it, right? So these are bad ways to present, and you've all probably experienced this. And if you don't believe me and you haven't experienced it, this is an actual picture that I took from a talk that I was attending, a seminar several years ago. And I hope none of you on this call were the presenter. I'm fairly confident none of you were, but this was actually a nightmare. It was horrible. This slide, it took them about 15 minutes to get through the slide. Every single thing you see on here was added step by step, including like every level of the pyramid was added separately. And then each arrow flew in from a different direction separately. And by the end, I mean, nobody was paying attention to any of this. It was just a nightmare. So, excuse me. So if you don't believe that people really do this slide, you can even see the heads at the bottom of the screen to prove. I took this with my phone in this presentation specifically to use for future presentations of what not to do, okay? So people really do this, unfortunately, but don't be that person. So what should you do? How do you present effectively? I'm going to give you my strategies and my opinions, and you'll notice that I tried to be as consistent with this with my previous slides as possible. And it starts with beautiful images. It starts with making slides that they can look at. Now, my view of presenting is that the audience's attention should always be primarily on you. They are there to hear what you have to say as a researcher. And so give them something beautiful to look at, but not something that will take away their attention so that they're not listening to you. Most people cannot read text on a screen and listen to the speaker at the same time. So give them a beautiful, stunning image like this, something that they can look at, but allow them to keep their attention focused on you. All right, what else? Well, you should have consistent fonts. You should have contrasting colors. Remember a few slides back when I had yellow text on a white background? You may not remember because you might not even have been able to see that, right? Contrasting colors are much more effective. So try to use that whenever possible. There's a lot of debate that you hear about, is it better to have dark background with light text or white background with dark text? There's been studies on what's more effective. What I'm going to tell you is my personal opinion, which is that you should do whichever one you prefer. Go with what you like. You know, presenting information is a lot like, you know, when people are writers and they say you have to find your voice as a writer. Similarly, when you're presenting your research, you sort of have to find your voice and your identity as a researcher and as a presenter. And so if you like dark slides with white background and you think that's more visually striking, do that. If you prefer the opposite, do that. But as long as you have contrasting colors so that everything is legible, that's what really matters. You'll notice most of my slides, either it's just an image or I have an image with minimal text. Try to keep the text to a minimum on each slide. A single image is better. You saw that previous slide where I had 5 data slides or 5 data figures on one slide. You couldn't read a thing. You didn't get anything out of that. One message per slide, be very clear what your message is for that slide. And then when you're done, move on. And for that image, try to find an image that tells a story. We talked all about why storytelling is important. Try to find an image that tells a story. Now, I love this image. This is actually from a research talk And as you're looking at this, I haven't told you anything about what the research is, but you're probably looking at this and already sort of telling yourself a story about what's going on here. I love this image. If you want to know the story, I'll tell you, this is a peacock, and people were studying mate selection, and they wanted to know what were the elements of the peahen, which is the female version of the peacock. What were the elements of the peahen that the peacock was looking at when what was getting his attention as he was sort of identifying whether he wanted to choose this particular peahen as a mate. And so they wanted to study the eye movements of the peacock. And hopefully you can see this on the screen as I move the cursor around. But the thing on the top of the head is a camera. It's a teeny little camera. It's actually the camera from a cell phone that they pulled out and they mounted on a little headgear. And it's projected onto the little square thing, which is right there. And that square thing is a mirror. And so the camera was focused on a mirror, which reflected the movements of the peacock's eye. And so they could see exactly where the peacock's eye was going and what he was looking at as he was looking at the peahen. Now, did you need to know that whole story? Probably not, but it's interesting research, so I thought I would share it with you. But I think that this image is so striking and really grabs your attention. And once you know the story behind it, this image makes so much more sense. So, you know, imagine explaining the research without having an image like this to illustrate your point. It would just be so much harder to do, right? So think about how you can find that image or set of images that will tell the story for you, that will do the work of storytelling. And then the final point I want to make is think about your slides or your poster, not as a script, but as a cue card. So if you put all of the text that you want to say on your slide, then people are going to be reading your slide and they won't be listening to you. Similarly, if you put all the text you want to say on your slide, then you're going to be reading from the slide. You're going to be paying attention to the slide. You're going to be looking at the slide, which means you're probably not going to be looking at your audience. And you always want to have eye contact on your audience. So rather than putting all of your text on a slide, think of it as a cue card. Put just the minimal amount of words you need to help you remember what you want to say. And then know your slides well enough that you can keep your audience, your attention focused on your audience at all times. And again, use that slide as a cue card and not a script. Okay, that's actually my last slide. It's 2:59 where I am. So we only have a minute for Q&A, but I want to stop there. I want to thank you all for your attention, your participation. It was great talking to you, and I'm really excited to read more about the research that you're doing and hear more about it. I want to thank Sigma Xi again for inviting me to share all of this information with you. And again, I want to encourage you, if you have questions, feel free to reach out to me directly by email. I will put my email address in the chat one more time. It's jory@duke.edu. There it is. Reach out to me if you have questions. Thank you for your attention, and I'm happy to stick around for a few minutes if you have questions now.
Chanel has also posted a survey for everyone. It would be great if all the participants could please make sure to open that before the session ends so you can complete the survey. It's very quick and we really appreciate it.
And I would love to thank Jory and Vanilla and all of you, our attendees, for joining the session. And Jory will be presenting at the Student Research Conference and the annual meeting. And his presentation is entitled Communicating Your Science to an Audience of Everyone. So please, if you have not yet registered for the conference, I have just added the link to the chat.